Welcome back, everyone. In this lecture, we're going to shift focus from columns to rows. Specifically, we're first going to learn about the index, so what is a good index and how we can set a column as the index or reset our index. And then we'll also discuss how to grab information based off the rows, whether it's a single row or multiple rows, or if it's a row based off its integer location or its labeled index name. Let's head back to the Jupyter Notebook that we were working with previously. Okay, here I am at the same Jupyter Notebook from before. I've called dataframe.head so I can see my data frame as well as the first 5 rows. And you'll notice automatically when you read in a dataset with pandas and you don't specify what the index column should be, it will automatically say a range index starting at 0, stopping for however many rows you have with a step size of 1. And a lot of times this will be fine for us, especially when we move on to machine learning. We're probably most of the time just going to have the default range index. But when it comes to things like exploratory data analysis, that could be things like just simple statistical analysis on your data set, or more complicated things like later on we'll learn about visualizations. Sometimes you're going to want to actually set your index to a value that is currently a column. So your index, the way we set up our data, should be a primary key or primary ID. And that term just means that the index should be a unique identifier for that row. Now, this isn't always the case depending on what you're actually working with as far as the context of your data goes. But in general, when it comes to machine learning and making sure our data sets are set up correctly, we want the index to be unique for every single row. So obviously, if I say range index starting at 0, stop at 244, step size of 1, the index here is going to be unique for every row. There's only an index of 0 one time. There's only an index of 1 one time. Only an index of 2 one time, and so on. So the range index basically automatically takes care of this for you, and it will go ahead and make sure that each of these index positions, or index labels I should say, is unique. Now, if we scroll over here to the right, I can see I have a payments ID column. And that's a column that we created for you that can be used as a labeled index. So each of these values is unique in this payment ID column. And you can kind of just take my word for it because we went ahead and constructed this payment ID column for you. But keep in mind, you will always want to explore that. And we'll show you different useful methods for that called .unique and .nUnique, which are just different methods of understanding how many unique values you have in a particular column. But for right now, we'll operate under the assumption that payment ID is a unique value for every single row. And so what we want to do is show you how to set up this column as our index. So right now, if I say df index, it's a range index. But if I want to set it to a column, then all I need to say is df dot set index, and then pass in the string of that column. In this case, the string is payment space ID. So we'll go ahead and do that. We'll say payment space ID. And if we run that, now you'll notice immediately we went from 11 columns to 10 columns. And if you scroll back up here, the way Jupyter shows this, and Pandas in general, is it will first, on the very first line, display the column names. So I can see total bill, tip, sex, smoker, etc. And then what we have here is on the second line, you'll notice our index says payment ID. Payment ID is not a column. It's actually now the name of the index. And it tries its best to show you this by basically putting it on a new line. So we have the column names, and then because we set the index to payment ID, it's essentially now the index has a name, payment ID, and these values in bold are the index values. So just keep that in mind that this is not a column, even though it kind of looks like one. It's actually the name of your index. Something else to keep in mind is that the setIndex method does not actually occur in place. If I were to ask for df head again, we actually still have that range index. If I want this change to be permanent, up here, make sure I have 10 columns always, and make sure payment ID is the index, then I'll say df is equal to df.setIndex. And this is technically a command that you should only be able to run one time, because once you set the index, payment ID won't be a column, so it's not like you can run the cell as many times as you want. So keep that in mind as well. Sometimes beginners make the mistake of accidentally running this cell twice, and then it starts complaining that it can't find payment ID as a column, which makes sense because you already set it as the index. So we're going to run this, and now this change should be permanent. And if I run df head, now I get to see this payment ID as my index. And so I can actually grab things based off this payment ID. So let's go ahead and show you quickly how to reset the index. So let's imagine this was a mistake, or you have an index that you want to set as a column instead for analysis purposes. All you have to do is say df.resetIndex. And this doesn't take any argument because it's just going to grab whatever the current index is and set it as a new column. So we'll say df.resetIndex. You can see here we're back to 11 columns, and then it went ahead and pushed payment ID forward one or up one, so now it's a column, and we're back to the range index. As you probably guessed, if I say df.head, this change is not permanent unless I scroll back up here and say df is equal to df.resetIndex. And now the change is permanent. So that's the very basics of setting the index to an existing column or resetting the index, meaning grab the index and place it as a column. All right, so to continue on here, what I'm actually going to do is I will set the index to this payment ID column. So let's say df is equal to df set index and then payment ID. And now that I have this index, what I want to talk about is actually grabbing rows. Let's talk about grabbing a single row. Now you have two options here. One is to grab it based off the integer location, essentially its numeric index, or its labeled index location. So for this, we use df.iloc, and this is going to be the integer-based location. Essentially, if you want the very first row, well, that would be at index 0. So note here that $16.99 is the very first row here. So if I say .iloc, square braces, then I get essentially a series returned of that row's information. So I can see here I have total bill $16.99, 101, and so on. Now, if I want it based off the labeled index, then instead of .iloc, I just use df.loc, and this is the label or name-based index. And then as a string, I pass in whatever label I want. In this case, it looks like it's Sunday 2959. So we copy this as a string, put it in, and then this is the labeled index. So two different ways of getting the same information. This one, iloc, is going to be dependent on you knowing the actual location you want, and .loc is just going to be dependent on you knowing the label you want. Now let's talk about grabbing multiple rows. So for multiple rows, you have a couple of options here. Again, if we want to grab multiple rows based off of .iloc, I can actually use Python's slice notation for this. So what I can say is if I want to grab rows 0, 1, 2, and 3, then I can say df.iloc 0 colon to 4, and this is essentially going to slice the data. So what we can see here is it starts at index 0 and then goes up to, but not including, index 4. So I get back the first 4 rows, 0, 1, 2, 3. And this is the same slicing notation that's standard for a Python list. So this is why some people will often use .iloc, because it then allows you to do this sort of slice notation. Now let's imagine we wanted to grab multiple rows based off a labeled index, so these actual names here. Well, I can do that too, very similar to what we did for grabbing multiple columns. I'm just going to pass a list into this .loc call. So what we're going to do here is have another set of braces, and then say something like, let's say we want Sunday at 2959, and then we'll say, let's also grab Sunday at, let's say, 5260. So you can see here, I'm just passing in a list of those string labels into .loc, and I get back those 2 rows. So you have 2 methods here, iloc, integer-based, or loc, string label index-based. So now that we know how to grab a single row or multiple rows, let's talk about removing rows and inserting new rows. If I want to remove a row, I actually use the same .drop method call as I did for a column. So I just need to say df.drop, and then since I'm using a labeled index, payment ID, what I have to do is tell Pandas what label I actually want to drop. So in this case, let's go ahead and drop 2959. So I just copy this, and I say df drop this particular row value, and then you'll notice that before we mentioned you have to label the axes. So 𝒂𝒔0 refers to the actual rows here. So by default, you can just say df.drop without specifying the axis if you intend on dropping a row. But just to make it clear here, if I say df.drop Sunday 2959, you'll notice now that very first row I had with the $16.99 has been dropped, and it returns back the full data frame with that row missing. Now, something to note here is that this change is not permanent unless you actually reassign it. So if I scroll back down here and say df head, then you'll notice that Sunday 2959 is actually still there. If I wanted to make the drop permanent, I'd have to say df is equal to df.drop this row. And now when I call df head, notice that the very first row of 1699 and a tip of 101, I run that, it's no longer present. So it's been permanently dropped in place. Again, that's just the reassignment. Okay, so we know how we can drop a row. Something to keep in mind is that if you have a labeled string index and you want to drop something based off its integer location, you cannot say something like df drop 0. This will actually produce an error. So if you run that, it's going to say, hey, 0 is not found in 𝒂𝒔s. So if you have a labeled string index and you intend on dropping a row, you'll need to provide the actual correct string ID here. The alternative, if for some reason you did want to do a selection or drop rows based off of the integer-based location, then technically you could just start doing slicing. So you could say df ILOC starting from index 1, go all the way to the end. Kind of depends on the exact situation and what you're actually trying to do with your data frame here. So don't think of just dropping rows, also think of selecting only the rows you want. Often it's easier to think of it that way as only selecting the rows you want versus dropping the rows you don't want. Sometimes that selecting logic is a lot easier than the dropping logic. Okay, so I'm actually not going to run this. So we can still have our data frame here, 243 rows since we dropped one, and we have the 10 columns. Let's talk about inserting a new row. So your new row, it needs to match up with the dimensions of your current data frame. So let's go ahead and say one row is equal to df.ILOC0, which would be the current first row in this data frame. So I have one row here. It's a series, and its index matches up with my columns. So this is ready to go, and it's correct. We can't just add in a row with saying like total bill is $10.34, and it's missing every other piece of information. What you need to do is make sure that it has the index here that matches up, at least in length, with what the data frame expects here. So keep that in mind. The data itself can be missing, but it has to be the correct length and shape in order for us to append it. And so all we need to do here is simply say df.append, and then we say one row, and let's go ahead and say df is equal to df.append one row. So now if I check out my data frame, it has 244 rows, and you'll notice that the very first row we grabbed here, Sunday 4608, has now also been appended to the very end. You should also notice here that Pandas isn't actually going to complain if this payment ID index is the same for both. So it's just something you should be aware of. Typically, if you're keeping this index, as we mentioned, especially in machine learning, we want these to be unique. So we wouldn't actually do this sort of operation of kind of duplicating a row. Later on, we'll show you how to drop duplicate rows. But that's the very basics of dealing with rows. Typically, as far as this course is concerned, the only thing that we'll really be doing here is either calling .ILOC or calling .LOC, depending on the format of the index. We won't actually be appending single rows one at a time, because realistically, that's not what we're doing with large data sets. We're typically just reading in the entire data set. Okay, so we know everything we need to know about rows, and with that, we've actually finished the very basics of data frames. Coming up next, we're going to discuss conditional filtering, a very powerful tool that allows you to select things based off logical conditioning. Let's go ahead and see you at the next lecture.